Hello and welcome to the channel. In my last video, I did a comparison between each generation of Apple Silicon MacBook and a high-end Windows machine. The conclusion was that although every generation of MacBook was incredibly capable at the actual creation of the content, the M3 and M4 chips could also handle the task of rendering the actual project and do it in a pretty reasonable time. It's not that the other chips weren't capable of rendering because they were all impressive, it's just that the M3 and M4 did it significantly faster, and in my mind would be the ones that you chose not to wait until you were plugged in to render the project. Reading some of the comments on the video and on social media, a couple questions came up. The first was, could you realistically work away from an outlet and create and render your project entirely on battery? And the second was, how loud do the fans get when the machine was being pushed to the max during a rendering session? So I decided to do a few tests, rendering on the GPU and the CPU for 10 minutes, starting from a fully charged battery, to see how much impact there was to the battery life and how long it took the fans to spin up and get really noisy. Both machines are at 100% battery health and set to identical settings. Starting off the tests is Blender, rendering in cycles on the GPU. The samples are set slightly differently on each machine to get as close to exactly 10 minutes as I could. In the interest of time, I sped up the renders, but I will play a few seconds of the fan noise at each interval that it increased, all the way to the 10-minute mark. So as you can see and hear, the fans spun up a little sooner on the M4 and ultimately got a little louder than the M3. And even though the M4 finished sooner than the M3, it used more power to do so, finishing the test at 87% battery while the M3 used 10% battery in the same time to finish at 90%. Moving on to After Effects, which primarily renders on the CPU versus Blender, which was using the GPU, the fan noise was nearly identical as the Blender test, and the fans again spun up a little sooner and got a little louder on the M4. Although both fans seemed to be running at full tilt, they were still much quieter than the old Intel MacBooks running a heavy load and much lower than the Razer laptop, which sounds a lot like a jet engine taking off. And if anyone was wondering why I didn't include the Razer in these tests, if you've used a high-end Windows laptop before, you'll know that they have a fraction of the performance while running on battery. I did try a test render alongside the MacBooks, but ultimately decided not to use the results as they didn't really fit in with what I'm trying to show here. Just like in the GPU test, both machines continue to show 100% battery through the first half of the 10-minute test, and don't start registering a drop until close to the 6-minute mark. From here, and again like the Blender test, the M4 starts to pull away from the M3 and drop a little quicker, slowly at first, but then as the fans really kick in, you can see the M4 really start to drain faster. In fact, both the M3 and M4 were about 95% at the 8-minute mark, which is where the fans really started kicking in. From there, the biggest drops happened in the last few minutes of the test. The M4 began dropping very quickly, at some points even registering a 2% loss at a time, showing that the fans spinning up to full tilt in the later minutes of the test seem to have a much bigger impact on both of these machines than in the first half when they are relatively silent. In the end, the CPU test seemed to be a little harder on the M4 MacBook than the GPU test, draining an additional 1% in the same 10 minutes, bringing the M4 to 86%, while the test was a little less draining on the M3, taking 1% less, with the battery finishing at 91%. Initially, I thought I had the results that I needed and started to put the results video together, but as I recorded the voiceovers and listened to myself, I started to wonder something else. In both tests, the percentage seemed pretty stable until the fans started kicking in around 5 or so minutes after set render started. After that, the battery percentage seemed to drop more quickly while the fans were really going. I wondered if I tried running short renders. That finished before the machine got hot enough for the fans to spin up. If the battery drain tests would fare better, since it could be the aggressive fans that was causing additional drain. So as one final test, I rendered the same 10 minutes in 1 minute chunks spread apart enough to allow the MacBook to stay cool enough that the fans didn't spin up. I honestly expected to get slightly better battery life, but I actually got significantly worse battery life. I tried things like turning the brightness down and closing the laptop between renders, but no matter what I tried, the end result was the same, a little over 1% drain per minute of active rendering. These results really got me thinking about the reason I initially made this video, which was trying to answer the question of if the new MacBooks are a solid all-in-one mobile solution, the keyword being mobile. In my regular testing, while plugged into a studio display on power, there was no question that it could be my desktop computer. It was the mobile part that had me wondering, is it a good solution if you are on the go, maybe in the field, with limited access to a power source? Could you realistically conceptualize, create, render, and publish your projects all on the battery only? My answer: it depends. Initially, I thought that the battery drain curve was flat for the first few minutes, and then dropped off sharply once the MacBook heated up and the fans kicked in. This curve made me think that it was possible to get more out of a battery by limiting your render to smaller, less than 5-minute chunks. The initial chart was very dramatic, showing no drain until the first 5 minutes, but that turned out to be a product of how the computer reported battery percentage, and the end result was the number to truly look at. When I ran the tests starting at 90%, the results showed a much less dramatic curve and corroborated my statement that active rendering on battery consumes a little over 1% per minute on the M4 Max and close to 1% per minute on the M3 Max. That tells me while it's technically possible to render on battery only, I definitely wouldn't start a long render while I wasn't plugged in, especially if there wasn't a power source nearby. So while I can edit video, 3D model, and composite all day, I'll definitely be saving the rendering for when I'm plugged into a power source. Hopefully you found this video helpful, and I'll have a lot more in-depth comparisons coming soon. But until then, thanks for watching, and I'll see you in the next one.